So to expand, we were looking at the 5th row. So we're going to write out the numbers for the 5th row. And then we're going to take each term. So we're first going to only look at the first term, which is A. We're going to raise it to the 5th power. And what I'm going to do is every time I go down, I'm going to change the power by 1. So it decreases by 1 every time. A to the first power is just A. A to 0 is just 1, so we don't need to write anything here. Then we're going to look at the second term, which is a positive B. Instead of starting on the left, we're going to start on the right. So this is going to be B to the 5th. And then I'm going down this way. And again, B to the first power is just B. B to the 0 is 1, so we don't need to write it. Every time, your exponent should always add up to equal 5. So 5 is here. We have 4 plus 1 gives you 5. 3 plus 2 gives you 5, so on and so forth. And then all you do is write your sign in between. And then look to see if there's anything we can simplify. In this problem, there is nothing to simplify, so we're done. Let's look at a more challenging one. We're still going to use Pascal's triangle. And we are going to look at this one. So our terms are a bit more advanced. I'm gonna move this up some. So this says to the 4th power, so we're looking at the 4th row. We're gonna write out these numbers. So 1, 4, 6, 4, 1. Again, looking at our first term, which is 2A. It's to the 4th power, 2A to the 3rd, 2A to the 2nd, 2A to the 1st is just 2A, and then we don't need anything here because anything to the 0 power is 1. We do the same thing for our second term, but again, starting on the right side. So it's negative 3B to the 4th, negative 3B to the 3rd, to the 2nd, and to the 1st, we don't need to write it. And in between, there will be plus signs. However, we have our negative, so this is going to change slightly. Now you can take your calculator. There is some simplifying that needs to be done. So we're going to do 2 to the 4th power. Remember, you use the caret to get the exponent, so it's 16. A to the 4th. We don't need the 1 because 1 times 16 is 16. Now we're going to look at 2 to the 3rd power. Gives you 8. And we have this 4 and a negative 3. So 8 times 4 times negative 3 gives us negative 96. Then we have A to the 3rd and 1B. Again, my exponent should still add up to my power, which is 4. I do that with this next one. I have 6. 2 squared is 4. Then I can do negative 3, put it in parentheses, to the 2nd power. And this square takes that negative away because a negative and a negative makes it a positive, so we get a positive 9. Multiply that by 4 and by 6. We get a positive 216, A to the 2nd, B to the 2nd. Again, power should add up to the original power, which is 4. 2 more. 4 times 2. Then we're doing, in parentheses, negative 3 to the 3rd power. You want to put it in parentheses so the negative gets the exponent as well. We get negative 27. Times it by 2 and 4. We get negative 216, A, B cubed. Last one, we have 1 which times anything is itself. So we do negative 3 in parentheses to the 4th power, and we get 81B. And so this is our answer. So we can use Pascal's triangle to expand a polynomial. There's one other thing I want to show you. So now, if I don't want to sit here and do all of this work every time, there's a shortcut if I'm just trying to find one term. So we're going to expand this term, and then I'm going to show you just how to look at, say, if I want to find the 4th term or the 7th term. So we're going to use this binomial theorem, and this means combination. So if you see this right here, It means a combination. And we're gonna use the calculator to do this for us. So here, I'm always gonna have my power be what goes first here. So I want combination 6, and we're looking at the 0 term. I'm gonna take my first term, which is 3x, and then this is gonna work the same way we did it with Pascal's triangle. So let's go to the 6 power, second term is raised to the 0 power. Because remember, if I start this way, when I get to here, it goes away. So when we put this in the calculator, you're gonna hit math,